Ok, empezamos. Ahí va. Hello guys, in this video, I'm going to show you how we can compute the color mean from one RGB image. I'm going to compute the color mean from one channel of one image or one RGB image. I'm going to get the red channel and compute his color mean. Sorry, speak Spanish. El color promedio. This is a color aesthetical feature. Also we have the standard deviation and the skewness. But the first step that I did was get the color mean in order to detect if in my case the lemon fruit is mature or green. In this paper this man did the same, but also he get textural features using GLCM matrix. These features are from Geralic features. These are very powerful for get features about the texture of one fruit. But in my case, I'm going to classify fruits by the grade of the color. I'm going to classify lemons, greens, matures, and middle matures, or pintones in Spanish. I'm going to show you my dataset of image. I have three classes. The first class is the mature lemons. As you can see, here are my mature lemons, and the next class is the pinton. This is semi green, not total green. It's medium green. As you can see, the pinton lemon has yellow parts and green parts, but the green lemons are totally green, are full color of green. I have by the moment 300 images per class. If we have a big dataset, is more better. In my case, I have 300 images per class. Okay, so what I want to do is get the color mean of this RGB image, but I need to avoid these black pixels because the zero values can affect the median. I only need to get the median of the colorized image of the lemon. I don't need the zero values. Well, how we can do that? Well, I have two solutions. The first solution for get the color mean is using MATLAB, and the second solution is use Python and NumPy library. Well, I got the color mean in MATLAB to try to compare the values in Python. MATLAB confirms that the value that I got in Python is equals to MATLAB, and then there is no problem. This was the first problem that I I found. But now that I found that the values that I got in Python and MATLAB are equals, there is no problem, because because the, here you see this is the mean of the RGB image, the same image that I showed you before, this picture. But you can see that this value is very slower. It's was affected by the 0 pixels, black pixels. I try to remove that 0 pixels. Here you can see it using NumPy, but this solution is bad. I prove it using MATLAB, and these values are back, no are good. So now let's start. I'm going to read the image in MATLAB and get the color mean of the red channel. I need to get to the mean for the 3 channels R, G, and B. In total will be 3 features of the mean, and then I'm going to get 3 features for the 3 channels of the standard deviation. 3 features, 3 plus 3, 6 features, plus 3 features of skewness. Well, so let's start. To read one image in MATLAB is very easy. We create a variable called image, and then we write it emRead. I am in this patch. You can move with cd in my patch folder X. No? So I am ready. I'm going to read the image emRead verde is the image. I'm going to show the image as you can see here we have our image of the lemon. So now I'm going to get the red channel. It's very easy. Image, the variable image, we access that, we get the red channel of this way. Number 1 for red channel. If we want to get the blue channel is 3, green is 2, and red is 1. I'm going to try to show that red channel. Here we have the red channel. What happens if I get the green channel? No. This is different in Python using OpenCV, but there is no problem. I only going to get the red channel. Okay, so now we are going to create a variable called mean or out, and we are going to exclude the 0 values using this sentence: mean non-zero and the matrix red channel. You can see here the value From here we have the values, the intensities of the RGB components, non-zero and R channel, out, sorry, non-zero is not defined, set no zeros, and the mean is 29.68 50. So the value will be equals in Python, and so that's it. In MATLAB we got the mean using non-zeros into R channel from one RGB image. It's very easy. So let's go to try to do the same in Python. I going to this direction, to this path. I'm going to work inside documents, because here I have the image of the lemon. Lemon is here, lemon GPG. We are going to create a new Python 3 project, a new computer, Jupyter project. The first step is import OpenCV, and we are going to import NumPy, and also I need to use matplotlib, pplop, as PLT. So we are going to read the image cv2 emread lemon GPG, and I'm going to show the image of the lemon with plt show image and plt show. Here we have the original image. Now we are going to get the red channel. Easy, R channel. We are going to copy the original image copy, I'm going to try to show that red channel, plt show red channel, plt show. Sorry, to get the red channel we need to do this step. This is one in format in OpenCV. The sequence of the RGB image is BGR. The first channel in this case is B, and the second is G green, and the last is red. So let's go to get the red channel. Of this weight, I don't need the blue and green. Blue is the first channel of the BGR format. And then I need to remove the green channel. Is the second of the BGR format. And that's it. We are preserving the last channel, the number 2, that is the red channel. I'm going to show that red channel right now. BLD EM showed. BLD show. And here we have the red channel. I think that there is no problem. Let me see. Okay, I thought that there was a problem, but when I run the same code into Anaconda console, I did the same. I removed the B channel, green channel, using the BGR format. In the first index we have 0 for blue, and the next green is 1 and red is 2. But when I use Anaconda, I get the image with this color. It's in red. It's very rare, very weird. Yes, the color, the original image, his color is inside of Matplotlib. With Pplot, the color is distorted. It's different than the original. From the original image is different. And here the red channel is, the image has a blue color. But okay, so there is no problem. Let's go ahead, and we are going to see that we are going to get the same value. Let's go. So now we need to convert the red channel to one array of this way. Red array for red channel. We are going to use numpy and np as array, and we pass the red channel. We are going to print her shape. We got 480 and 640, 3 channels. Are inverted the dimension. First we have the height and the weight. I think the original image is 640 of height and 480 of weight. The weight is 640 and the height is 480. When we use OpenCV, this is inverted, so no problem. Now we need to remove the 0 pixels. We need to remove the 0 pixels and create one mask. So it's very easy. Let's go to get the man of this object. As I said, we need to remove the black pixels. How we can do that? Creating a mask of non-zero pixels and preserving the pixels which has values greater than 0. I going to create a variable called g, and now we are going to use numpy np in a masked where the variable which has the array of the image. In this case, the red array has the values of the red channel. Array equals 0, comma. Again, we put the variable who has the red values of the red channel. And sorry. That's where there is a problem. Sorry, I got one error from here. This letter is D, is not T, and so that's it. So now we need to get the mean value. How we can get the mean? Oh, we get the mean of this weight with this weight. I'm going to print the variable. Here we got the masked. This is the data, and the mask has 2 for values which are greater than 0, and the data type is 1 int of 8 byte. So let's go to print the mean value. We use the function mean from numpy, and we do passing the red channel who contains the values, but in this case we need to pass the variable who not contains the 0 values. We only pass this variable who is excluding the black pictures. And let's go. We got an array of 3 columns, 3 calls, and 1 row, a 0 row. Let's go to print median, the mean of the red channel. Print. Let's go to print the mean color average for the red channel, and here we have the mean color for the red channel is equals to matlat. Yes, 29.68 is equals to matlat. So let's steps is round this value to only 4 decimals, for example, and construct a future matrix of the next channels. So guys, that's it. I hope that it helps you getting the mean color from one channel, from one RGB image. As you can see, only we get the red channel, and then we create a masked with only with positive values greater than 0, and then we got the mean color average using numpy, the function called mean. In this axis, if you change 1 to 2, we are going to get the mean of no matrix, only of the weight, of the height, dimension. If you print the mean, will be different. This is a big matrix, but we use only the 0, 1 coordinates, and this is the mean. If we only want to get this value, it's very easy. We say the mean inside this variable, and we print out in the value 2, the index 2 who contains this value. Sorry, what happened here is 0, 1, 2. Mean is not defined. Sorry, my vision is filing. And the 2 index which contains the mean. So that's it. The next step for me is get the mean color average for the blue and green channel. I'm going to get 3 features, and then I need to get a standard deviation for the next 3 channels of the same image and the next skewness. In total will be 9 features. Well, that's it. The code will be in GitHub, and I hope that you are happy with this solution to get a mean color average from one channel. That's it. Let's go. That's